lesson 9.6, permutation. Permutation. Not a perm you put in your hair. Permutation is math word. Permutation. Okay, so permutations is kind of like the problem we just did. Okay, with the pin numbers. Yep, with the pin number. So, two vocabulary words I have. Okay, so arrangement, how things are arranged. A lot of times they talk about people, letters, numbers. People, letters, numbers, and then permutation. The order is important. So we're talking about the order today. That's really important. So remember when we talked about the triplets one where you asked me, well, some of these are the same as the others, remember? Okay, so today that's where we're going to be actually looking at the order that things are happening in. So that's really, really important today. Order is important. People, letters, and numbers. So I'm going to need 3 volunteers. Cadence, Connor, Josie, come up here. Actually, we can do 4. Come up here, Mr. Augustine. Oh, no, now he's hurt. Oh, now he can't come up here. All right, so are all you guys off for track? You guys are all off for track? Oh, this is so perfect. These are all the people off for track right now. They're all running a race against each other. Look at them. Yeah, Cadence is in first right now. Okay, so these people running their race. It's a really tight race. How many possibilities are there to get first place? How many people have the 4 people get first place. 4 people have the chance to get first place. Oh, Josie was the fastest. Woo-hoo! Josie gets first place. Yay for Josie. Now, sorry. Oh, I don't know. Maybe he's got a cramp. He's cramping up. Okay. Since he just hit himself. So now Josie got first place. Now, how many people have the possibility of getting second place? The girls are schooling you guys. I don't know. Okay. Third place. How many people have a chance to get in third place? 2. Oh. How many have a chance of getting last place? 1. Okay, so this is what I mean. Order is important today. So we're looking at how many possibilities can be first. How many possibilities can be second, third, and fourth. Thank you. Sit down. That was fun. Good job, ladies. He was the last one to raise his hand anyway, so he came in last. So. All right, like I just said, example, meddling in a race, lining up. Those are different kinds of permutations that can happen. So when you go to your track meet on Monday, think of the possibilities that could happen on your race, okay? So, factorial. Here's another vocabulary word I have for you, and this is actually one of my favorite vocab words because you use an exclamation mark in math. Often to use an exclamation mark in math. Never, but it's actually a symbol that we use in math. It's pretty neat. Used to write a product when the factors are consecutive whole numbers. And I will show you how this works. Make sure you get the symbol written down. Okay, so before, when we did our race, this is what the possibilities were, right? Like first place, there's 4 possibilities. Second, there were 3. Third, there was 2, and the last there was 1. So if I multiply these together, I actually have I had 24 possibilities of you guys lining up and medaling. Okay, even though Cadence came in first this time, that doesn't mean next time that Ryan would come. Okay, so there were 24 ways that those people could have been lined up in the medaling order. All right, so you're kind of like, well, what does this have to do with it? You can actually write this using a symbol, and it would look like this. 4 factorial. That just means it's 4 times 3 times 2 times 1. Okay? Because what's that? It's an order all the way down to 1. Yep, it's an order all the way down to 1. Nope, it only means going down. Yep, so I'll do another one. So if we have this, let's say I have 6 exclamation mark, that means 6 times 5 times 4 times 3 times 2 times 1. It goes from that number all the way down. And the reason why we have that is because think about it. Think if we have 21 factorial, then that does happen. Do you want to write 21 times 20 times 19 times 18? No, it's going to take too much paper. This is just a shortened way to write it. Just for multiplying. Yep. Yeah, technically you would solve it, but maybe they would ask you something like this. I know this isn't in your homework, but I just want to show you what this looks like. Maybe they'd say, okay, if I have this, write that in factorial form. That's it. Okay. So whoever thought you'd see an exclamation point in math? What? Your minds were just blown this morning. Maybe. So this is just a way you can write something like this. Okay. If you ever see this, that's what it means. And believe it or not, even on your calculator, if anybody has a calculator like mine, your calculator has stuff like that on it. If you have one like this, it has stuff on it. I'd have to find it for you though. Let me see. Okay, so if you have one like mine, and if you don't, that's okay because we can figure it out. I know yours is on there too. So. Does anybody have one like mine? Just you too? You too? Okay. Okay, there's a probability button on here. It says PRB, and it's like kitty corner from second. If you push that, do you see this exclamation point over there? You can actually use that. So like if you would put in, let's put in 21, and then you put in 21, and then you push your probability button, you go over to your exclamation point, you'll say an enter, it'll say 21 exclamation point, and then you can push enter, and it'll tell you what 21 factorial is. It's actually really neat. Did you find yours? I'll show you. Probably have to figure, oh, right here. Okay, so this, you see the exclamation? So let's try that. So I do this, and then second, and then, yeah, that's what you'd have to do. 5, and then second, and then that one right there. Anybody else have one? Yep. So like if I would put in, let's say if I put in 4 factorial, 4, and I want the factorial, I push PRB, and I go over, enter. It's pretty neat. Did you figure yours out, Jacob? Not that I'm going to let you use your calculator, but I just think it's interesting. So there's right there. So I do 6, shift, this one, and that's how you do it. 3. Anybody else? You find yours? Well. Oh, here. It's above the 3. So like if you do 6, and you would do your factorial, you do shift, and then 3. And that's like 6 times 5 times 4 times 3 times 2 times 1. Isn't that cool? Yeah, see, yellow numbers, it's kind of like a keyboard. The yellow numbers, you actually have to shift it to make that button work. Like in the keyboard, you have to shift it to make your, it's the, like the thing it's on. There's different things you can make it so it does, and that's the stuff. So here's your PRB button. So let's say you want to do 4 factorial, second, or actually second, you do PRB, go over to that, and then enter. That's like doing 4 times 3 times 2 times 1. Yep. So let's see here. Probability button's right here. So let's try 8 PRB, and then you would go down to 3. Enter. And that's like 8 times 2. 7 times 6 times 5 times 4. So you want to help with find yours too? Yours is right here. So like, let's say you want to do 5 factorial, 5 times 4 times 3 times 2 times 1, 2, 5 times your second, and then 3. And that's your answer. Isn't that cool? Your calculator can do a lot of stuff, especially with probability. Yeah, this can do a lot of stuff with probability, believe it or not. So, kind of cool, just a little tidbit of information. Okay, so let's try some of these, shall we? So here's an example. Your iPod, is that like a thing of the past? What do you say now? Oh my gosh, okay. Your iPhone has 5 songs on it. What's that? I know, but I don't know if people use those anymore. Yeah, an iPad. Your iPod has 5 songs on it. That's it. You don't want to listen to any of the same songs twice. Find the number of orders the songs can be played. Okay, so let's think of the orders of the songs. So this is your first song, second, third, fourth, fifth. For that first song, how many possibilities do you have? You have 5, right? For the second, multiply them all together. Let's see, this is 20, this is 6. You're going to have 120 possibilities that those songs can be played on your iPod. That's how many different combinations there are on your iPod for just those 5 songs. That's it, 5 songs. Yeah. So imagine even 6 songs. 6 songs would take it up another notch. 6 would be, I think, 720, 740 or something. I don't remember, but I know I saw it. So, this is an example of what you're going to see today. Okay? To me, it's pretty simple. As soon as you think of it, you're like, oh yeah, duh. You can only have 5 for the first one, 6 for the third, 4 for the second. I don't think so. I mean, not outrageously high. Like 21 factorial is like 5 million or 5 bajillion on your calculator. So no, it's not going to be too high. Okay. Yep. Are you writing that down? Sorry. Sorry. Okay, ready? Alright, so in a bag there are 4 chips numbered 1 through 4. How many combinations can there be picked out if they are not replaced? Well, this is kind of like the one we just did with the people lining up. 4 chips, there's 4, 3, 2, 1 possibilities. Multiply them all together, you get 24, right? This is another one I want you to see. This is another one I want you to see. And make sure you probably want to have this one written down because I know this is one you're going to see in your home, or one like it. So this time, 8 people are going to run in a race. But like when you guys go, only a few people get medals. Not everybody medals, right? When you run. Maybe like the first 3 or the first 4. First 6. First 6. It's okay. Today only the first 3 do, so they're going to whittle it down to 3. 8 people run in a race. Only 3 get medals. I want to know how many different ways medals can be given out. So are we finding all 8 places this time? How many places are we only finding? Just finding 3 places. First place, second place, third place. And multiply between. So 8 people run a race, 3 are given medals. I want to know how many different ways these 8 people can medal. So for your first place, how many people can medal? 8. That's it. Okay, what about your second place? What about your third place? How many places are we only medaling to? 3. We don't have to go down to 1 this time. So could I use 8 factorial here? Could I use that factorial symbol? No, why not? It doesn't go to 1. Very good. So now I'm going to figure this out. So 56 times 6. 6 carry the 3. multiply together, there's 336 ways that these 8 people can medal in the top 30. That sounds like a lot. That's a lot. So you've got to be careful what you're asking you. Maybe they're going to say, okay, there's 4 runners and they're all going to medal. Then you would have to go down to all 4 places. They might say, well, there's 10 runners and only 5 of them are going to medal. So then how many places do you go? Only 5. You have to figure out how many places they actually want you to go. Okay? Yeah, so if you on your calculator say, oh, I'll just do 8 factorial, you're not going to get the right answer here because 8 factorial would be if you're medaling for 8 places. 8 times 7 times 6 times 5, and we're not doing that. So you have to be careful there. Okay? So be careful what they're asking. Okay, last thing, let's see. Let's do this one. Let's do this. This is a different way to show a permutation. So this is a way to show you, to have you do a permutation without giving you a story problem. Okay? And you were like, oh, yeah, that's what you're talking about? All right, so this means right here, permutation. Okay? And then they're going to have, like, the P, and then they're going to have 2 things in parentheses. And those 2 numbers actually mean something. So the first one means that's the number you're going to start with. For example, there's 10 runners in the race. Okay, so that's the number you're going to start with. That third one tells you maybe how many places they're going to medal. So how many places they want you to go. So this would actually make you look like this because the 10 is what you're starting with. Yep, and you have 3 places. Yep, so that, yes, if it was 10 to the 10th, yeah, it'd be factorial. Yep, but if it would be like 10 to the 6th, then you go 6 places down, right? So you have to know what each part means. So the easiest thing to do here would be to get it mixed up. Sometimes you could do that, sometimes you couldn't. Because if you start with 3, can you go down 10 spaces? No. So think, common sense, think about it. First one is the first one number you start with. The second one, how many places you're going to go. Any questions so far? And then solve it. Like, let's see, I know this is 72, so this is 720. So this they might not have a story problem with it. So you have to know what each part means. Okay? So if I ask you this one, let's just write them out together. What does this actually look like? 8 times 7 times 6. Very good. What's this one actually look like? Yep. Yep. Good. Nice job. And then you would multiply them. That's all for these type of problems. You don't have to do anything else. Okay? Then you got to figure them out. That's just the next step. Do you guys have questions for me? Okay. Let's go back to, I'm going to run back to this one. Right here. Oop. Right here. The members of student council are shown. Okay? What is the probability that Jake is selected the president if Tina is selected vice president? First of all, before I figure that out, do I need to figure out how many combinations I have? I do. I have to figure out how many possible combinations I could have for these people. So how many people are there? 5. And how many, let's see, president and vice president? So I really only have to go how many spaces? 2. So for my first space, how many possibilities would this be like my president space? Yeah. And how many do I have for my vice president? 4. Okay. So how many possibilities do I have just for those 2 things alone? 20 out of all these. And what is the probability that those 2 are going to end up together? Just 1. It might be 2, but Jake might be the vice and Tina might be the president. It's 2, but we're actually looking for Jake just being the president and Tina being the vice president. So there's just 1 then. Yeah, if it's Tina and Jake being chosen, then it would be 2 because they could go in either category then. Does that make sense? That's what we mean that its order is important today. Yep. Then you have to think about it a little closer. Yep. See, see how it would just be 1 because that those 2 are going to end up in that spot together. It'd be 2 chances if it said, well, what are the chances that Jake and Tina are just going to be together in those positions? Then it would be 2. But 1 because they want that specifically. Okay. Questions for me? Pretty easy, right? I think this is kind of fun, believe it or not. No, it really is not. And the good thing is you had an idea of what it was before you even came because we talked about with the card, the PIN number. Yep. Yeah, it is kind of fun.